we are going to learn about our topic number 15, C's memory structure. So let's look at C's memory structure. So in the previous video we have talked about that how variables is declared and its mechanism, and in this video we will learn about the memory structure of C. So let's look at it. So C memory map, we can say, because the memory is mapped in C language. Okay, so when a C program is compiled successfully, it creates and uses 4 logical distinct regions of memory to hold the program executable code and data. So this is very interesting point and very interesting fact about C language, that whatever you use, whatever you create a variable, how you use your function, how you use your structure, that is going to be allocated in the memory, and it has 4 logical distinct regions of memory to hold the program executable code and the data whatever you have written in it. So in the C memory we will learn about that how the C language is going to store its executable code, that whatever the code we have written in C language, that how it is going to hold the program's executable code and the data. So let's look at. So here the reason. First reason is called the program code. Second reason is called the global code. Third reason is called the heap, and the fourth reason is called the stack. So there are 4 logical distinct regions of memory to hold the program executable code and data, and this is what we call C's memory map. That is the mapping of the memory in C language. So first reason is program code, second reason is global, third reason is the heap, and fourth reason is stack. So let's look at the program code, global, heap and stack. What the meaning of stack, what the meaning of heap, what the meaning of global, what the meaning of program code, and what it is stored, what kind of executable code it is stored, what kind of data it is stored. Let's look at it. So point to be noted down, and this is very important point, that what kind of the code it is going to store, you will get that thing from here. The first reason is that memory which hold the program executable code. So we have talked about the first reason, that is the program code. So it will hold the program's executable code. Okay. So first reason is that memory which holds the program executable code. Okay. Moving on the next one, that is the second reason or the global reason. Second reason or the global reason or permanent reason is the memory where all the global variables and static local variables are stored. So every global variables as well as static local variables are going to be stored here in the second reason, that is the global reason or what we say permanent reason. And finally the third reason or the heap reason is the free memory, which is used to hold the dynamic variables created during execution of the runtime. So we can say that in our first reason it holds the program executable code. In the second reason, that is the global reason or we can say permanent reason, that is used to hold all the global variables and the static local variable were stored in this region. Third reason or the heap reason we say is a free memory. It is a free memory which holds the dynamic variable which were created at the dynamic time in the run time during executed time. So this is what it is going to be called heap reason. And the fourth and final reason or we can say stack reason is the memory which holds the return address of the function call, argument to the function, and all the local variables except static. It also stores the current state of the CPU. So we have one by one deal all the memory map. We have deal about the program code, that it holds the program executable code. We have deal with the globals, that it is going to store all that global variables and static variables were going to be stored in the second reason. We have talked about the heap and we have talked about the stack. Okay, so in the third reason or we can say heap reason, that is the free memory and it is used to hold the dynamic variables created during the execution or the runtime. And the fourth reason or the stack reason, we can say that stack region is that memory which holds the return address of the function call. So whatever the address of the function call, that will be stored in the stack. Whatever the argument to the function, that will be stored into the stack region. Whatever the all the local variables except static, that will be going to be stored in the stack region, and also the current state of the CPU is going to be stored in the stack region. And this is the memory mapping of the C language. So let's look at how it works. So here you are seeing a diagram. Here it is stating us that the first region, which is called the program code, it is holding the program executable code only. So it holds the program executable code only, and you are seeing here it is the global, and it is the second region, and it is holding the global variable as well as the static local variables. So in global region, global variables and static local variable are stored. In the region that is the heap region, or we can say third region, here you are seeing only the dynamic variable that were created during the execution of the runtime were stored in the heap region. And finally, you are seeing here is that it is the stack region where all the local variables, argument to the functions, and return address of the functions, as well as the current state of the CPU are stored here. So this is the memory mapping of the C language, and it is very important to understand before proceeding toward the programming, and it gives you the idea that how the C is going to work, So all the programs executable code is going to be into the first region, that is the program code. Global region, that is the global variables, and the static local variable will be stored here. In the heap region, all the dynamic variables, as well as what we can say that were created during the runtime or the executable time, were going in the heap region, and the stack is going to store all the local variables, argument to the function, and return address to the functions, and also the current state of the CPU. So this is the C memory mapping. Now let's look at the working process of it. The working process is so simple of it that it is going to store the program's executable code, program code. Global is going to store a global variable and a static local variable. Heap is going to store dynamic variables. Stack is going to store all local variables, argument of the function, and return address of the function, as well as the current state of the CPU. So this is the C memory mapping. So thanks for watching. Dhanyavad.